For the transmit part of a transceiver, we need to convert an electrical signal into a modulated optical signal. If you want to find out how we do this, stick around and we'll check it out. One typical system for digital signals is the so-called binary or NRZ signal. This basically means we have two states, it's the 0 state and the 1 state, and if we now put this into a sequence with zeros and ones, we have the information which is transferred. And now the question is, how can we transfer it or convert it from the electrical side to the optical side? And there are basically two possibilities. There's the so-called direct modulation, the DML, and this means we are taking the laser and switching it on and off. The second solution is the EML, the externally modulated laser. This means we have a laser running continuously, and by means of a kind of a shutter system, we can modulate the binary sequence to the optical signal. So how does this work? First of all, we have to take a quick look at the principle of interference of waves. We have a green and a blue wave. They are completely identical, and in the upper sketch they are perfectly in phase. This means the interference is constructive and the resulting red signal has double of the amplitude. In the bottom situation, it's a little bit different. We have a phase shift of 180 degrees between the two signals, meaning they are cancelling each other out and the resulting signal, the red one, is 0. This principle now is used to modulate optical signals in a transceiver. Here depicted we have a Mach-Zehnder interferometer named after the two inventors, Mr. Mach and Mr. Zehnder, who did the invention in parallel. And at the input we have a laser running continuously, and the laser light is hitting the first beam splitter here. So we have two beams, the blue one and the green one. And at the end here, the two signals are recombined again and they can interfere. The trick of this setup is the orange box here down below. It's an optical component using the electro-optical effect. And the electro-optical effect basically means by applying a voltage, it changes the refractive index. And the refractive index change can be done in a way that we have a phase shift of 180 degree or 0 degree. This results in the situation that we can modulate the voltage by the binary sequence here, and at the end, where the recombination of the beams happens, we then get destructive or constructive interference, meaning we are modulating this binary sequence to this optical signal. So we had two situations or two solutions, the DML and the EML. And as always, there is not only one solution which is the best. It really depends on which transceiver you want to build and what is your situation. For example, the DML has the big advantage. It's a mature technology and you don't need any additional parts. The disadvantage is it's limited to 100 gigabit per second because you cannot switch on and off the laser faster, and it's only for short reaches. On the other hand, the EML, it's for higher modulation speed and the signal quality is much better, but it has higher cost and it adds more complexity to the system. I hope you learned something today. If so, please leave a comment and see you in one of the next videos. Bye bye.